Now let's have a look at the second problem where we asked to find general solution of the cos of 2 theta is equals to negative 5 over 6. So we're still following the same chain of thought where we just need to find the reference angle by finding the arcsine or the second function of sine in your calculator. But in our arcsine, we're only gonna substitute 5 over 6. What do I mean by arcsine? Remember, we need to find our reference angle by saying cos the power negative 1, open bracket, we don't substitute the negative, we only substitute the 5 over 6. And this is an important point to note. We don't substitute the negative because the negative sign helps us detect our quadrants. So in our classic cost diagram, we know that all the trig functions in this quadrant are positive, so we just leave it as our reference angle because we know that our reference angle will be less than 90 degrees, and we know that it's 90, 0 degrees, 180 degrees, 270 degrees, 360 degrees. We know that in this quadrant, we know that it's 180 minus, its sign is positive. In this quadrant, third quadrant, only sign is positive, for it's 180. In this quadrant, this fourth quadrant, 360 minus, where cos is only positive. So we have to find the quadrants where cos is negative. And we know that cos is negative anywhere else other than quadrant 4, meaning it's negative at quadrant 2 and quadrant 3. So all quadrants, all the three functions are positive, yeah, and none of them are negative. So cos is negative in quadrant 2 and quadrant 1. And that's very important to know because that's where we're going to use these quadrants to calculate our answers. So we're going to be really referencing quadrant 1 and quadrant 2, I meant to say, and quadrant 3. This is why we don't substitute the negative sign, and the sign gives us direction as to which quadrants we have to use to calculate our answers. And that's a very important step in general solution. So let's go ahead and solve this problem. So if you punch in your calculator the cos negative 1 5 over 6, you should get 33.56. Find out to the nearest second decimal. So since we found our reference angle, now we need to really calculate our two solutions. Remember we said we're looking at quadrant 2. So with quadrant 2, our solution will be 2 theta will be equals to, remember quadrant 2, 180 degrees minus our reference angle plus k times 360. Remember, plus k times 360 applies for sine and cos, but for tan it's plus k times 180 because the period of sine and cos are 360 and for tan it's 180. So in quadrant 3, we know that 2 theta will be equals to, third quadrant, it's 180 degrees plus our reference angle plus k times 360 degrees. Why are we saying 2 theta? Remember, this point of reference is 2 theta. If it was theta, we're only going to write theta. If it was 3 theta, we're going to write 3 theta. So don't make the confusion of just only writing the theta. So let's substitute our values and see what our answer would look like. So we just substitute our reference angle, which will be 33.56 degrees plus k times 360 degrees. then theta will be equals to 180 minus 33,56. We need to calculate what we get there. And then we divide that by 2 because of the 2 here, which we're going to get 73,22 plus k times, remember we're going to divide everything by 2, and 360 divided by 2 is 180 degrees. And the step of dividing by 2 is very important, and a lot of learners make that mistake, and they forget that you also need to divide the 360 to make it 180. And that's our first solution. And our second solution will be 180 degrees plus 33,56 plus k times 360 degrees. Theta will be equals to 180 plus 33,56 divided by 2. And then we should get 106,78 plus k times 180 plus 360 divided by 2 is 180. So these will be our two solutions. And we shouldn't forget to collect our free mark by just saying k is an element of z. Get a free mark for that. And then it really depends whether it's 4 mark, 5 mark question, and we would have collected all the marks that we need. Let's move on to the next question of general solution, where we have to factorize. But now we are given sine of 2x minus the cos of x. And if you pay close attention, you realize that we have a double angle of sine. Double angle means the angle of the variable x is multiplied by 2. This is equals to the sine of x. Cos of x, it means in place of sine 2x, we can just replace that and substitute it with 2 sine x times cos x. So we can go ahead and do that. Cos of x minus cos of x is equal to 0. Since we're factorizing, you see that we have a common factor of cos of x, means that we can take out the cos of x as a common factor, and we have 2 sine of x minus 1 equated to 0. Remember, general solution is like solving for x. You have to factorize and find the factors, but in this time we're working with trig ratios. So we're going to say cos of x is equals to 0, or 2 sine of x is equals to 1 when you take the 1 over to the equals to sign. So we have sine of x is equals to 1 over 2. So this is a crucial and important step where we have to have a trig ratio equated to 0. Trig ratio equated to a number of 0, trig ratio equated to a number 0, where now the trig ratios are isolated. So it means we're going to be working with 2 trig ratios, the first being the cos and the second being sine. So importantly, always have to remember our cos diagram. When you're doing general solution, the cos diagram is a very useful tool. I would say it's a tool that you use in every single question. It just depends if you want to always write it down or you have it by memory. But for the sake of this video, I always write it down for every single question, so as it's second nature. So many things in maths is all about recollection and pattern recognition. So there'll come a time where you don't need to rewrite a cos diagram all the time, but it's already embedded in your mind. I think that's the ultimate goal. So in the third quadrant we have 180 plus, in the second quadrant we have 180 degrees minus. In the first quadrant, we know the first quadrant is just the reference angle, all the trig ratios are positive, and the fourth quadrant is 360 degrees minus. So we have the first quadrant, second quadrant, first quadrant, second quadrant, third quadrant, and fourth quadrant. So let's move on to calculating our reference angle. So our reference angle for cos, it will be the cos, the second function of 0, and put that in your calculator to get the reference angle. The cos is 90 degrees, and then we find the reference angle sine, which will be second function of sine of 1 over 2. So in your calculator, you can either say shift of sign depending on the calculator you have. Then you substitute your half into brackets and you get 30 degrees. So we have two reference angles, 90 and 30. 90 is for cos and 30 is for sine. So it comes to a crucial step now where we have to identify our quadrants. So I'll start with the cos so as to not confuse things. So for cos, you can see that we said cos of x is equals to 0 there. And cos of x is equals to 0 simply implies that 0 is positive. It means we're looking for quadrants where cos is positive, which is quadrant 1 and quadrant 4. So for quadrant 1, we know that since we work with a variable of x will be equals to our reference angle plus k times 360 since it's cos. And then we have quadrant 4, which is x will be equals to 360 degrees minus the reference angle plus k times 360 degrees. So we can go ahead and substitute. So the reference angle here is 0. No, it's not 0, it's 90 degrees. It's 90 degrees plus k times 360. That will be our first solution. For quadrant 4, we have 360 minus 90 plus k times 360. So simply going to say 360 minus 90 degrees, it'll give you 270 plus k times 360. And we know where k is an element of C. They always give you marks for writing that. So this will be our solution. Get a mark on that, we'll get a mark on that, and we'll get a load of marks in factorization. So remember, these solutions are for cos. So we've done cos. We need to come back and do that same thing for the reference angle of 30 degrees for sine. So let's go ahead and do that. For sine, we know that sine is positive because sine of x is equals to a half. Means we look for quadrants where sine is positive, and sine is positive in the first quadrant and the second quadrant. So we'll be working with quadrant 1, where the variable now is x. We're working with x is equals to the reference angle plus k times 360, and quadrant 2, where x is equals to 180 minus the reference angle plus k times 360 degrees. So we just substitute our reference angle, which is 30 degrees plus k times 360. Then we move on to the next. Quadrant 2 to be 180 degrees minus 30 degrees plus k times 360. Where x will be 180 minus 30 to be 150 degrees plus k times 360 degrees, where k is an element of Z. And then these will be our solutions. And that's how really you factorize something as complex as a double angle minus cos is equals to 0, and then you find the relevant general solutions. And I would say one of the most important vehicles for that is also understanding your cost diagram. So let's move on to the next question and also break it down and see how we can go around it. Let's move on to the next question on general solution. We have to factorize the sine of x squared minus 1 minus cos. So the first thing that we need to do when you're given a situation like this is just we have to convert sine squared x into a trig ratio the same as cos. The easiest way to do that really we know the identity sine squared x and cos squared x is equals to 1. So sine squared x is equals to 1 minus cos squared x. It means instead of writing sine squared x, we can write 1 minus cos squared x. And since then the trig ratios will be the same in the same equation, it will be easier to simplify. and factorize. But if you had a different approach and said you wanted to change costs, there's not a way of changing a cost to becoming a sign. So that was one hint as to how to solve this problem. So we can go ahead and substitute 1 minus cos squared x is equals to 1 minus cos x. What we then do, we can take everything to the left hand side, so it will be easier to simplify. And remember that anything you take across the equals to sign changes its sign. So we'll have 1 minus 1, that those will cancel off. And then we're left with cos x minus cos squared x, which is equals to 0. So we can see now that we have common factor of cos of x and cos of x 2 times the cos of x here, which will give you cos squared x. So we can just take out 1 cos x here, you'll be left with 1 over there, minus, if you remove 1 cos x from there, you will be left with 1 cos of x equals to 0. If you always want to check if you did the right thing, just multiply this back into the brackets and it should take you back to this answer over there. So what we then do, we need to find the cos, which will be equals to 0, or we'll have 1 minus the cos of x is equals to 0, which is the same as 1 is equals to cos of x, which is cos x is equals to 1. So we go ahead and find our reference angle. Our reference angle is equal to the cos minus 1 of 0, and the cos of 1 of 0 gives us, punch it in the calculator, 90 degrees, and the reference angle there is the cos minus 1 of 1, which will give us 0 degrees. So the important step now becomes that of knowing which quadrants we're working with. And if you've watched many of my videos, you notice that I always go to lengths to redraw this Cartesian plane over and over again. It's just so I realize the importance of it, because without it, it's hard to find the correct answer. So in the second quadrant, we have 180 degrees minus. In the third quadrant, we have 180 degrees plus. And in the fourth quadrant, we have 360 degrees minus. And we have our cost diagram. And we'll be using our cost diagram to answer the rest of this question. So let's first work with cos of x is equals to 0. Cos of x is equals to 0. The reference angle is 90 degrees. So if cos of x is equals to 0, 0 is a positive number, meaning that we're going to be working with cos is positive in the first quadrant and the fourth quadrant. So we'll be working with quadrant number 1, where the variable in question here is x, where x will be equals to our reference angle plus k times 360 degrees. So our first solution will be 90 degrees. That's our reference angle plus k times 360. And we're also in quadrant number 4, where our variable in question, which is x, is equals to 360 minus our reference angle plus k times 360, and x will be equals to 360 degrees minus 90 degrees plus k times 360, which will give us x is equals to 360 minus 90 will give us 270 degrees plus k times 360. So we're done with cos of x is equals to 0. We have to look at cos of x is equals to 1. How do we go about that? Cos of x is equals to 1. It's where cos is positive. It's positive in the first quadrant, and it's also positive in the fourth quadrant. So it will be Q1. First quadrant, as we said, will be x is equals to the reference angle, and the reference angle here is 0. 0 plus k times 360 degrees, and x will be equals to k times 360 degrees. And if we move over to quadrant number 4, it will be x is equals to 360 minus the reference angle. The reference angle is 0 plus k times 360. So therefore, x is equals to 360 plus k times 360, where k is an element of z, of integers. And then we would have found all the relevant solutions for cos is equals to cos of x is equals to 0 and cos of x is equals to 1, and also k is an element of z. So let's move on to the next question, where now if we're given an interval where we need to find the possible values of theta. So we're given that the 3 sine squared theta is equals to 2 sine of theta. And we have to find the general solution for this, but they're giving us an interval. So this interval might look intimidating, but it isn't, because just because it has a negative angle doesn't mean that it's impossible to solve. So let's go back and look at our cost diagram here and really break it down and study it. Because remember, all these angles are measured in an anti-clockwise direction, right? But what then happens when you measure your angles in a clockwise direction, meaning that when you move from there to there, what then happens? It means that this angle here will become minus 90. This angle here becomes minus 90 because you're starting from here, going here, and then this angle here will be minus 180 degrees, and that angle will be minus 270 degrees, and that angle will be minus 360 degrees. So if they're asking you for negative 360 to 180, what are they asking you for? Negative 360 to 180, negative 360 is here, and if you have to go back to positive, it means you go back that way, and then you will land at what? 180. So you could make an argument that negative 180 and 80 is the same thing. Same way you would make an argument of saying 0 and negative 360 are the same thing. Yes, because if they'd said the interval of 0 to 180, it'll be the same interval as that. So it means we'll be focusing on these two quadrants in this question. And that's very important, as we'll see as we're answering the questions as we move along. So let's start with our factorization and see what we have to deal with in this. So we're given sine and sine, so we can just bring everything to one side of the equation and start with our factorization. Minus 2 sine of theta is equals to 0. So you notice that we have a common factor of sine theta. If we remove sine theta, they will be left with 3 sine theta minus 2, which is equals to 0. Where our first solution will be sine theta is equals to 0, or 3 sine theta is equals to 2, where the sine of theta is equals to 2 over 3. So these are our critical trig ratios, and we'll be working with them to find the values that we need to answer this question. So the sine of theta is equals to 0. We need to find the reference angle for that. So the reference angle will be equals to the sine second function of 0, which will give us sine second function of 0 will give us 0 degrees, and the reference angle for sine theta is equals to 3 over 2 will be equals to sine second function 2 over 3, and this will give us 41,81 degrees. And if you notice that sine theta is equals to 0, which is positive, sine theta is equals to 2 over 3, which is positive. So raise sine positive. Sine is positive in the first quadrant and in the second quadrant. So we'll be working with only quadrant 1 and quadrant 2, and the same thing for sine theta is equals to 2 over 3. Those are the two quadrants we'll be working with. So let's go ahead and do that. So quadrant 1, we know that in this case we're working with theta, not x, because the question is in theta format. Or if we go back, we'll see that we have theta as our variables. So we're going to be using theta as our references. So quadrant 1 will be theta is equals to, in quadrant 1 we know that it's what? It's always our reference angle. It's k times 360 degrees. So theta will be equal to reference angle, which is 0 plus k times 360 degrees. Then we said we're also in quadrant 2, theta will be equal to 180. Remember, quadrant 2 is 180 minus quadrant 1 is always the reference angle. So it's 180 degrees minus our reference angle, which is 0. It's k times 360 degrees. And theta will be equal to 180 degrees plus k times 360. So these are part of our solutions. So let's highlight them. Let's move on to the reference angle of 41,81 degrees. Sine is positive. Remember we said in quadrant 1, so we know quadrant 1, theta will equals to reference angle, and the reference angle is 41,81 degrees plus k times 360. And also in quadrant 2, where we know in quadrant 2, 180 degrees minus your reference angle. So theta will be equals to 180 minus the reference angle. We should get 138,19 degrees plus k times 360 degrees. And those will be our solutions. The solution over there and that solution. Now comes really the important part. We still need to figure out the values that we need to substitute into our solutions. I'll say solution 1, 2, 3, and 4. And we need to find solutions in between this interval that was given. So the interval that was given was negative 360 to 180. So we need to figure out solutions that satisfy that. So how we need to do this is to just construct a table. So I'll try to erase everything that we will need so as to make space for this table, because this table is very, very important. So we have to construct a table where let's write down theta is equal to 0, k times 360, or rather theta is equal to 0 plus k times 360 degrees. Theta is equal to 41,81 degrees plus k times 360. And then I'm just listing out all the solutions so as to make everything easy. Then we have theta is equal to 180 degrees is k times 360. Theta is equals to 138,19 degrees plus k times 360. So what we need to do here, just needs to construct a small BD table. Just to have all the solutions that lie in between our interval. So in this table, to make things easy, always use 0, -1, 0, and 1 to give you all the solutions you want. So what you're going to be doing here, it's okay, I should have taken these a bit up. So we're going to be working with -1, 0, and 1. What we're doing here, we're going to take -1 and substitute it with its k. Then if you take -1 and substitute it with its k, you're going to see that you're going to have -360 degrees. Take -1, substitute it with its k here. Then you see that you're going to have -18,19 degrees. Take -1, substitute it there, you're going to get -180 degrees. Take -1, substitute it with its k there, you get -221,81. Take 0, substitute it with its k there. Let's pretend 0 is a different color. Let's pretend it's green. Take 0, substitute it with its k. Then you're going to get 0 degrees. Take 0, substitute it with its k over there. You're going to get 41,81 degrees. Take 0, substitute it with its k. You're going to get 180. Take 0, substitute it with its k. You're going to get 138,19 degrees. And continue with the same process of substituting 1 with 1 with the 360. A bit cumbersome, but it's worth it because you're going to get all the necessary marks. Take 1 and substitute it with its k, you're going to get 401,81 degrees. Substitute 1 with its k, you're going to get 540. Take 1 and substitute with its k, you're going to get 498,19 degrees. So, and then most important part of using the -360 and 180. What happens then? We're looking for all the values that lie in between here, -360 and 180. So what we're going to do, we're going to say all the values should be what? Theta, right? What lies between, including, because of solid brackets, -360. We have one value there, -360 is there. So we're going to write theta is equals to -360 degrees. Which other value lies in between there? -318, -318,19 degrees. And the next value that lies in there, it's -221,81. And the next value is obviously -180 degrees. And the next value is 0, because remember you're moving from negative to positive. It'll be 0, and the next value 41,81 degrees, and the next value would be 138,19 degrees. And the last value before 360, well, before 180, I mean to say, it is 180, so, and 180. So these are all the values that lie between -360 and 180 when you solve the general solution for that question. And once you've done this, you would have gotten all your marks. So this interval is important after you found your general solution.